Welcome to Study Loop.
Okay, hello. I'm going to be doing problem 19 from chapter 22, section 3 in the book Physics Principles with Applications. It goes as follows. Pulsed lasers used for science and medicine produce very brief bursts of electromagnetic energy. If the laser light wavelength is 1062 nanometers and the pulse lasts for 34 picoseconds, how many wavelengths are found within the laser pulse? How brief would the pulse need to be to fit only one wavelength? So the first thing I like to do is figure out what I have. I have the wavelength, which is 1062 nanometers. And I have the length of time of the pulse, which is 34 picoseconds. Okay, so by the way, nanometers would be 1062 times 10 to the negative 9 meters. And then picoseconds would be 34 times 10 to the negative 12 seconds. Okay. Then I would draw a picture to help me visualize. So we have a length of time which is 34 picoseconds. And then we need to figure out how many waves, which is 1062 nanometers, fit there. Okay, so the equation we're going to use is the wave speed equation, which is speed is wavelength times frequency. Since this is an electromagnetic wave, we're going to be using the speed of light. And since we do not know the frequency, we're going to rearrange it to solve for the frequency. I'm going to erase my little picture because I've run out of room, and then we can proceed. So now I'm going to use my speed equation and the numbers I have. So our speed of light is 3 times 10 to the 8th divided by our wavelength, which is 1062 times 10 to the negative 9. When I divide that, I get the frequency equals 2.8 times 10 to the 14 hertz. Now, if you remember, hertz is the same as 1 over seconds. So that means if we get the reciprocal of that, we will have the time. So the time would be 3.5 times 10 to the negative 15. So this is going to be our second answer. So how brief would the pulse need to be to fit only one wavelength? That would be the time. Okay, so now we will go back. Just keep that here. That's our second answer. We will go back and make a ratio of that with our original time that they gave us to figure out how many wavelengths fit. So we will do the original number, 34 times 10 to the negative 12 divided by 3.5 times 10 to the negative 15, and the number of wavelengths equals 9.7 times 10 to the third, or 9,700 kilometers.